Today we're looking at simultaneous equations by elimination. Now your typical question will look like this. Two equations, two letters or two unknowns, and we start by labelling the two equations so that we can refer to them easily in our work later. Now in the past you've always been used to equations that have just one letter. Here we have two equations with two letters. Each equation represents a line on a graph. You could find what that line looks like by making a table of values and plotting the coordinates that result from that, and same here. What we're going to do is we're going to eliminate either the x or the y from what we're looking at. And I would suggest that you always start by thinking about a subtraction, just because it's much easier to change that symbol into an addition if we change our minds later. Let's have a look and see what this does. 3x take away a single x will leave us with 2x. Positive y take away a positive y. Now, you should know from your numeracy that in this situation, a negative and a positive, right next to each other, they will combine to make a negative. So what we've actually got here is positive y take away y, which will leave us with 0y, or just 0. So this achieves what we want it to achieve. It removes the letter y. So let's follow this through. 3x take away a single x is 2x. Positive y take y is 0, so I'm going to leave that blank. And 11 take 7 is 4. We've now got a very simple equation. We're going to divide by 2 to get the x on its own. We're going to keep things balanced up by doing the same on the other side. And we discover that x equals 4 divided by 2, or just 2. X equals 2. We move on to the next stage of the solution, and we substitute this value, x equals 2, into either equation 1 or equation 2. It doesn't matter which, but you're probably wise to go for the equation that is simpler. I would judge probably equation 2, it has smaller numbers. So we'll substitute this value into this equation. And the equation said x plus y equals 7. And we now know that x is 2. So substitute that value into the correct place. Solve this equation. Take 2 from here, take 2 from here, and discover that y equals 5. So if we're correct, then these lines intersect at 2, 5. However, it's always nice to know that you're actually correct before you move on. And we have that option here. So we can check our answer in, again, either equation that we started with. But we did use equation 2 here, so let's use equation 1 up here. So check in equation 1. 3x plus y equals 11. I'm not actually going to write all of that down. I'm just going to write down 3x plus y. Hopefully we'll discover that as we substitute in the values of x, 2, and the value of y, 5, hopefully, remembering BIDMAS, hopefully we'll discover that 3x plus y does in fact make 11. And sure enough it does. So we're confident now that we have that correct. Now, we'll look at one more example. In the example that we've just done, it was the y values that were eliminated first. Let's look at another situation. 4x plus 3y equals 23, and 4x minus y equals 19. Let's try this question. Label them. Consider whether we should add or subtract them, but try a subtraction first and see what happens. Okay, 4x, take away 4x, that's very straightforward. That is going to make 0x, or 0. So immediately this is the correct option. So we're going to go with the subtraction. 0 there. Positive 3y, take away negative y. Now this is a little bit more awkward than the last example, perhaps, but again I hope that you understand that two negatives here will combine to make a positive. If we hadn't written that negative there, we would struggle to get this correct at this stage. So positive 3y plus a single y makes 4y, and 23 take 19, 4. Solve this. Divide the left hand side by 4 to get the y on its own. Do the same thing on the right hand side and discover that y equals 1. So this time we've discovered the y value before the x value. Substitute y equals 1, the value we've just found, into the easier of the two equations. Now, that negative, you could argue that that's making it more complicated. Perhaps it is, perhaps it isn't. But I think I'll substitute the value I've found into equation 1 this time. It doesn't really matter too much. 4x add 3y equals 23. 4x add 3 times 1 equals 23. 4x add 3 equals 23. We'll subtract 3 off here to get the 4x on its own. Match it up on the right hand side. So that 4x equals 20. Divide through on the left by 4. Match it over here so that we discover that x apparently equals 5. So if we're right, then these two lines intersect at an x value of 5 and a y value of 1. Let's see if we're right. Check in, now I used equation 1 here, so I'm going to use equation 2 this time. Check in equation 2. 4x minus y apparently equals 19, should equal 19, but let's find out if it does. 4 times 5, take away 1, 20, take away 1, equals 19, and we're happy that we've got it right. Please look at my next video to consider some simultaneous equations by elimination, which are a bit more difficult. This is the easy beginning of the topic. It does develop further.